Okay, so this problem is solving question 2 in homework 8.5. So the force F required to compress a spring by a distance of x meters is given by F equals 10x. And we want to find the work done in compressing the spring from x equals 1 to x equals 5. So let's draw a picture of what they're talking about. So we have a wall right here. And then there's a spring extending from that wall. And when it's at rest, this is the end point, and we'll call this the equilibrium position. And that's going to be called x equals 0. And then we are going to put on the 1 and the 5, the locations we're interested in compressing from x equals 1 to x equals 5. So we want to know if we start already compressed here, so we've already compressed the spring from equilibrium to 1, how much more work do we have to do to compress from 1 to 5? So we're going to pick a random location for x. I'll put it right here, like a little slice of the spring. This is slice at location x. Okay, so I've put it before my 1 and my 5 because I need to compress the spring all the way to 1 and then to 5. Okay, so work to compress from x equals 1 to x equals 5. We could calculate that by figuring out the work from rest to 5, right? From equilibrium to 5. And this would be done exactly like the problem in our notes, okay? So to calculate the amount of work done from rest to 5 would be exactly like from our notes. But we're not going from rest, we're going from 1. So we have to subtract the amount of work that we've already done to get from rest to 1, okay? Because that work is already complete. Work from rest to 1. And that problem, we do exactly like the problem in the notes to calculate the work from rest to 1. So the work from rest to 5, we say, okay, well, we're going to integrate from 0 to 5 because we're going from rest to 5. And the work, the force is 10 dx. Okay, so the work is 10 times distance, and we're just moving a tiny distance, dx. Okay, and then we're going to do that over, so that's my force, and then over a distance of 5 minus x. Okay, and then I have to subtract the same setup where I'm calculating work from rest to 1. So I'm going to integrate from 0 to 1. Again, my force is 10 dx. Okay, because it's, the spring has, we're compressing it just a tiny little amount for dx, and then adding up all those little amounts over the distance, 1 minus x. The total distance is 1 minus x. All right, so that comes out to 125 minus 5, which is 120.